So now questions related to redox reaction. Aluminium react with aqueous alkali to produce hydrogen gas. And by considering the change in oxidation number of aluminium and hydrogen, uh, it can be deduced that the reaction 1 mole of aluminium produced. So we have to write equation, a balance equation. So aluminium is there, reacted with an alkali. So it is producing, example, reacting with sodium hydroxide. And as a result, what will happen, because the reaction, it will produce aluminum, the hydrogen gas is there. So in terms of change in oxidation number, we don't have to write the full equation, because if we work out in terms of change in oxidation number, we can just mention. So when you see the change in oxidation number, aluminum is 0 as a metal, but when aluminum will form a compound, aluminum will be +3. So aluminum 0 changes to +3. So this change is oxidation. And in sodium hydroxide, OH hydrogen ion is +1. And this +1 becomes 0. So if +1 becomes 0, that changes reduction. So number of electron lost by one should be equal to number of electron gained by the other. So for aluminium, to convert into aluminium ion means it is losing 3 electrons. And for hydrogen +1 to change to hydrogen atom or a hydrogen molecule, H2 is produced. So one hydrogen should gain 1 electron, but because it's one hydrogen should get 1, but there are 2 hydrogens, so they should get 2 electron to be a hydrogen molecule. Now, to write a balanced equation, the number of electrons lost by one should be equal to number of electrons gained by the other. So what we will do, if we multiply, because 3 and 2 are there, so if we multiply this equation by 2, so this will be 2, this will be 2, and this will be 6, and this bottom equation we multiply by 3, so this will be 3, 3, and 3. So when we simplify, sorry, this will be 6, 3 multiplied by 2, 6. So this electron will cancel, and when we write the equation, we need the relation between aluminium, so 2 aluminium plus 3 hydrogen ions gives 2 aluminium ion plus 3 hydrogen molecule. So in the question they are asking what is the ratio of 1 mole of aluminium produces how many moles. So aluminium to hydrogen gas, what is the ratio? 2 moles of aluminium give 1 mole of 3 moles of hydrogen gas. So the simplest ratio is 2:3. But for 1 mole of aluminium, how many moles of hydrogen gas should be there? Produce X, cross multiply. So the simplest, if 2:3, then it will be 1:1.5. That's why the value of X will be 1.5, or it will produce 1.5 moles of hydrogen gas. Is it clear? The standard reduction potential of two systems are shown. Sn2 4 plus is there taking 2 electron, so turn into the electrode Sn plus 2, the electrode potential is 0.15, and iron 3 gain electron turn into iron 2, the electrode potential is 0.77. What are the component of a cell required to measure the standard standard reduction potential of iron 3 and iron 2 system? Look, as you can see, there is a change in oxidation number like +2 or +3. Either sorry, either +3 can change to +2 or +2 can change to +3. So whenever there is a change in oxidation number, but like metal atom is not formed, or metal atom or ions is not forming atom, or atom is not forming an ion, so that time the electrode which we use, that should be platinum. We don't need iron electrode, we need platinum electrode, so there should be a platinum electrode. and the electrolyte contain equimolar, like equal moles of iron 2 as well as iron 3. So if we are taking like example iron sulfate, iron 2 sulfate, so iron 2 sulfate will be FeSO4 and iron 3 sulfate will be Fe2SO4 in a bracket 3. So if we take equal amount of them, this will only give 1 mole of iron 2. And in the solution, this will give 2 moles of iron 3. So that won't be correct. That's why to make a balanced amount of iron 2 and iron 3, the solutions should also have the equal amount of these two ions. So how we'll have equal amount of these two ions? If we take equal concentration, so if this was 30 cm cube, then this should be 15 cm cube, like half volume. Half volume, and this will be double. So what will happen, because if 15 cm cube, ratio will be 1 is to 2, so the number of the moles or the ions will be equal. So ions in the solution should be iron 2 and iron 3, and the electrode which we use, that should be made up of platinum. Then the second one, what is the value for electrode potential of a cell? Uh, so how we can work out, look, tin 4 change to tin 2. So tin 4 changes to tin 2, that is 0.15. And iron 2 changes to iron 3. If iron 2, this is iron 3 change to iron 2, that is 0.17. But in the equation, they give iron 2 change to iron 3, 0.77 positive is there for iron 3 to iron 2. But in the equation, iron 2 is changing into iron 3, so it should be negative. So means this will be minus 0.77. So what is the total voltage produced? 0.15 plus minus 0.77. Because look what I'm doing, why I did not use that formula, that reduction minus oxidation, redox. We can also use that formula to work out, and we'll get the same answer. It won't make difference. So according to this equation, when we see the equation, tin 4 converted into tin 2, so that changes reduction. And iron 2 change to iron 3, so that is oxidation. So reduction potential is how much? 0.15 minus oxidation potential is 0.77. So when we substitute, we'll get minus 0.62. We'll get the answer. Or when equation is given, we can just use our understanding, like tin 4 changes to tin 2, so the voltage produced is 0.15. Whereas iron 2 changes to iron 3, the voltage should be opposite. Why? Because iron 3 to iron 2 is 0.77. If iron 2 to iron 3, it should be minus 0.77. That's why we took minus, and we'll again get 0.62 volts. So when we substitute, we'll get zero point 0.6 minus 0.62 volts. So negative cell voltage means it does not happen, it does not occur. In this question, the electrode potential of a cell is positive. It can be deduced. So what we can deduce about this, we know the electrode potential of a cell is directly proportional to total entropy, and it is directly proportional to ln k. So the value is positive. It can be deduced. The entropy of a system must be positive. That's not a complete, like the entropy change of a system must be positive. Not about the system, it is the total. Entropy change of a surrounding must be positive. That's not correct. Full. Total entropy should be positive. That's true. And entropy change of a system and entropy change of a surrounding, both must be positive. If, if both are positive, we don't have like, if electrode potential of a cell or a cell voltage is positive, it means the reaction is feasible. If reaction is feasible, the total entropy should be positive, and the total entropy should be positive, and total entropy is entropy change of a system plus entropy change of surrounding. So the entropy change of a system and the entropy change of a surrounding must both positive. So it's not necessary, it's maybe they are both positive, maybe they are not, one of them is negative, but we what we want the final answer, the result of these two should be positive. It does not matter when one is positive, one is negative. What we want the final answer to be positive. That's why C is the right answer. Is it clear? So this question is related to a fuel cell. We have electrodes. So we have first hydrogen gas. The hydrogen gas will break into proton, and the proton can travel through this proton exchange membrane, and the electrons which are lost here, these electrons will travel in the external circuit, and the majority of the electrons will be here. An oxygen molecule, hydrogen ions, and electrons, when they combine, they will give water molecule. So in terms of movement of electron, which one is a negative terminal? Where the electron originated, that is a negative electrode, and where the electrons move, that is the positive electrode. But in terms of oxid, because hydrogen molecule is losing electrons, so if it is losing electron, that is oxidation. So what we call this electrode, we call that as anode, because at anode always oxidation happen. So this is anode with reference to loss of electron, and this is cathode with reference to gain of electron. So anode and cathode here refers to loss or gain of electron, and negative electrode and positive electrode are referred for the movement of electrons. So first, what happened in the hydrogen fuel cell? Oxygen is, so what happened to oxygen? Oxygen gain electrons. So if oxygen gains electron, it is reduced. And which electrode, because this is positive or negative electrode, means in terms of electron. So in terms of electron, which electrode is this? That is a positive electrode. So D is the right answer. If they say oxygen is reduced at anode or cathode, so then we should write cathode. So cathode and anode, it is in terms of loss or gain of electron, and in terms of movement of electron, there is a negative or positive electrode. So this electrode is known as the anode, and anode here. Why it is anode? Because oxidation happened. And this electrode is known as cathode. Why? Because reduction happened. Is it clear, discussion about the hydrogen fuel cell? In the question, which electrode and the solution would be used to measure the standard electrode potential of manganese 3 and manganese 2 half cell? So you can see there's a change in the oxidation number, but it does not produce atom. Ions are not producing atom, or atom is not producing the ion. So it will be, which electrode we should use? We should use platinum. And it should have the equal concentration with respect to both, like both ions should be in equal amount, Mn3 and Mn2. That's why D is the right answer. So in this question, 1 mole of metal ion reacted in solution with 1 mole of sulfur dioxide. The half equation for sulfur dioxide is shown. The original oxidation number, or original oxidation state of the metal is +3. What was the number after the reaction? So look, when sulfur dioxide, this is the equation for sulfur dioxide, it is losing 2 electrons. So if there is a metal ion with a charge of 3 plus or plus 3, it is reacting with sulfur dioxide, SO2, not SO4. So if it is reacting with sulfur dioxide, if sulfur dioxide is losing 2 electron, the metal, because as I mentioned in the beginning, that the ratio 1 mole of sulfur dioxide reacted with 1 mole of a metal ion, so ratio between them is 1 is to 1. So if sulfur dioxide is losing 2 electrons, the metal should gain that 2 electrons. And when it will gain 2 electrons, what will be the charge left on the metal? The charge will be plus 1. That's why A will be the right answer. In this question, thallium-3 ions are oxidized by iodide, oxidizes iodide ions to iodine molecule. So the ratio between the thallium ions oxidize 0.0024 iodide ions. What is the oxidation number of thallium ion produced in this reaction? So we have to work out the ratio first. The ratio is 1 is to 2 here. The mole ratio for thallium and the iodide. So when we take a simplest ratio, it's 1 is to 2. So it means like two iodide ions are there which are reacting. So if two iodide ions are there, the two iodide ions, 1 is to 2 is the ratio, so one thallium is reacting with two iodide ions. And if two iodide ions are there, one iodide ion loses 1 electron, two iodide ion will lose 2 electron. So if iodide ion will lose 2 electron, thallium will gain that electron. So when it will gain that electron, but because two iodide will lose, one iodide is losing one, two will lose 2 electrons, so it will gain 2 electron. So if it originally it is plus 3 and gain 2 electron, so what will be the charge left now? So the charge left will be plus 1. So 25 cm cube of 0.01 mole per dm cube of vanadium 3 ions, so vanadium 2 ions, sorry, titrated with acidified solution of 0.02 mole per dm cube manganese 4. What is the volume in cm cube for a solution of manganate 7 ions? Manganate 7 ions, MnO4 is there, which are needed. So first we have the volume and we have the concentration. So when we multiply concentration with volume, we'll get the moles of vanadium plus 2. And after getting a moles of vanadium plus 2, we'll use the simplest ratio for 3 to 5 to get the moles of MnO4. And after getting the moles and the concentration, we'll find the volume. So first, we'll get the moles, that is concentration into volume. The concentration is 0.01 multiplied by volume is 25 divided by 1000. So 25 divided by 1000 times 0.01, this will give 0.0025, sorry, 00025 mole. And the ratio is 3 to 5 between MnO4 to vanadium. So if 3 to 5 is the ratio, if we have 0.0025, this will be x. So multiplied by 3 divided by 5, the answer will get the moles 0.00015. These are the moles we'll get for MnO4. But we need the volume, so concentration is moles by volume, so volume is moles divided by concentration. So we have the moles, we'll divide by concentration 0.02. This will give us 0.0075 decimeter cube. But all the answers are in cm cube. So to convert dm cube into cm cube, we multiply by 1000 That will come out as 7.5 centimeter cube. Manganese 7 ions MnO4 with a charge -1 reacted with ethane dioic acid. What is the change in oxidation number of each carbon atom in this reaction? So how to work out the change in oxidation number? So when we write, this is a compound which contains carbon, so it is C2O4. The whole is having a charge of 2 minus. So carbon is unknown. So oxygen, because it belongs to group 6, each oxygen is -2, 4 oxygen will be -8. So because the overall compound is -2, so means what should be the total carbon? It should be +6, because +6 -8 give -2. So if +6 for 2 carbon, for each carbon it will be +3. And in carbon dioxide, CO2, each oxygen is -2, so 2 oxygen will be -4. So one carbon is there +4. So that is plus. So what is the change in the oxidation number for each carbon? +3 become +4. So that's by, it changes by 1. The standard electrode potential of silver ion to silver atom is given, which is the only suitable chemical for solution. So whenever we use a substance as a like solution for a salt bridge, it should always be an aqueous solution soluble, and all nitrates are soluble. That's why directly we'll write D as an answer, because it's a nitrate salt and all nitrates are soluble. So as a salt bridge, the solution, like the filter paper, this should have an aqueous solution which is soluble, and all nitrates are soluble, so we select potassium nitrate. The cell below was set up copper as a negative electrode. So if copper is as a negative electrode, means what is the movement of electrons? So movement of electrons are from copper towards the other side. Okay, so it means oxygen should gain electron. So the solution is on the right hand beaker contain a suitable electrolyte and a phenolphthalein as an indicator. After some time, the solution on the right turned pink. So phenolphthalein is colorless in acidic. When it turned alkaline, it will become pink. So the question is, they give you the answer directly, because if turned pink, it means OH is produced. So which equation OH is produced as a or a product, that is C. And the second thing, another thing which explain that because oxygen should gain electron, as oxygen is a positive electrode here, so when the in terms of movement of electron on the positive electrode, the oxygen should gain electron. So which equation it is gaining electron, that is only C. The rest all, like equation A also, it is a gain of electron, but why A cannot be an answer? Because A is producing water as a product. So means it make a neutral solution. In the question they mentioned phenolphthalein turned pink. So phenolphthalein is in colorless in acidic, but in alkaline it turned pink. Is it clear? So in this question, which of these species is strongest reducing agent? Reducing agent means itself it is oxidized, and oxidation means loss of electron. Which one can lose electron? Chromium plus 2. Look, chromium 3 gain electron turn, because it's a negative. The one, how to identify which one is a better reducing agent? The one which is having more negative value in term, or you can understand like the product side, because you have to check whether reactant they're asking or a product. So they're asking for chromium 2. So chromium 3 gain electron, it is negative. So it means when chromium 2 loses electron, happen oxidation will happen for this. So this will be plus 0.41 volts. When we check chromium 3, it is negative. Negative voltage means like it is not feasible that so chromium is not it is not losing electron, it is gaining electron. So oxidation is not happening, reduction happens. For chloride ion, when we check for chloride ion, for chlorine to convert into chloride ion, it is 1.36. Then for chloride ion to lose electron, then it will be minus 1.36. So means it is not feasible. It is not feasible for chloride ion to lose electron because it will give a negative voltage. When we check for chlorine, so for chlorine molecule, it does not lose electron. Chlorine molecule changes by gaining electron. So it cannot be oxidation, it is a reduction. So it cannot be chlorine as well. So we are left with A as a chromium. Is it clear? First part. Then the second one, which halogen or halogens will oxidize chromium 2 to chromium 3 but not chromium 4 under standard condition. So we have to check the electrode potentials here. If we check with the bromine, 2 to 3 can be done, but not to 4. So example, as you can see here, chromium 3 and 2, this one is there. And in dichromate, it is plus 6. Plus 6 to plus 3. Now, if we check with the bromine, so the equation which we will take, so chromium 3 to chromium 2, first we'll check with the bromine. So which one is having a higher voltage? This one is having a higher voltage. So it means reduction happen for this and oxidation happen for this. So reduction happen means bromine molecule will turn into bromide ion, and oxidation happen means like chromium 2 will change to chromium 3. So this will happen. But whether 6 will convert into 4 or there's a reaction between them. So we check now the equation of a bromine with equation of chromium. So when we check the two, so it means this one oxidation, this one higher voltage, so reduction happen. Reduction happen means 6 will change into 3. But for the other equation, oxidation happen, loss of electron or reverse will happen means. Like bromide ion will change, not the bromine molecule. So when chromium plus 6 changes to chromium 3, reduction happen, and the bromide ion must change to bromine molecule. Not so bromide ion can carry out this change, not the bromine molecule. So it is valid for bromine. Now same thing, we will check whether it is valid for chlorine. Chlorine or iodine, we will check. So if we check with, or now we are checking example with iodine, does it happen? Because the chlorine option is only one option contain chlorine, most of them are bromine. So if I work out iodine with iodine, it happens, so I can get the final answer. So example, this is equation A, and I'm checking whether iodine can react with like convert chromium 3 to chromium 2, chromium 2 to chromium 3. So when we check, this is a higher voltage, so oxidation happens. So iodine molecule turned to iodine, and then reduction happens. So means in this case, the chromium 2 will change to chromium 3. sorry, I wrote opposite, like reduction happen here because the higher potential. So this will be reduction happen and oxidation. So this reduction happen and the other one oxidation happen, loss of electron. So means iodine will convert chromium 2 into chromium 3. That's true. But then we will check this iodine with chromium 6 equation, whether it will happen. So when we check which is the higher voltage, this is a higher voltage, so it means reduction happen here. If reduction happen, the other one should be oxidation, and oxidation is the loss of electron. So opposite will happen. Means this reaction can occur with iodine, not with iodine molecule. So iodine can react and convert 6 to 3, but not iodine molecule. So that's why D is the right answer. As they mentioned, which can oxidize chromium 2 to chromium 3, but not chromium 6 under standard conditions. Is it clear, discussion? So this was about all the redox reactions. Next session we will do more questions.